Hello everyone. In this tutorial, I will show you how to create a basic crowd simulation in Tyflow using TyActor. I have a really basic animation, basic character here, a walk cycle and a run cycle. So let's do a birth surface. I'll select the plane and I'll select just the first vertex or the last, just one. And let's add an actor object. And I will move the bones to another event. Let's add object bind. And I will select my terrain here. And you can snap to surface. So if I put this one over here and I moved it around, you'll see that the actor just snaps a recast on the plane. So let's start with walk cycle. I'll name this event walk. I'll send over my actor and I will add a speed operator. And I know because I've tested this before that the correct value for this walk cycle is 0.23 centimeters. And I have this on negative. And I will type here the name of the animation. And I will do 10% blend, 10 frames, sorry. So as you see, this is a correct speed. I will set it to loop. And if I added the object bind here as well, I have to set this friction value to 0. So it just followed the terrain. If I have multiple actors and I want them to have a variation in the speed, all right? It's like over here, if I have, let's put 65, something like that, they will not be synced anymore. As you see here. So there's a cool feature here in actor operator. You can multiply speed by velocity. And I know the correct speed is 0.23. So you just put it here in velocity threshold and Tyflow will sync the animation based on this threshold. Whatever the speed is, the animation will be synced correctly. If you're using particle physics and using particle physics in multiple events, all right? And you'll go and let's make this instance. And if you go and show the collision shapes and the neighbors, and you will check this one off. Okay, and let's give it more space here, let's 3 centimeters. You will see that particle physics calculates everything, like even the bones, which creates this weird behavior because there's so much to calculate and it doesn't make sense to calculate the bones. So what you can do is use simulation group. And if I set this to 1, for example, and I group these actors objects to group 1, let's find the group operator. And I'll put this right after the actor, so the bones don't get grouped to group one. Now it will only calculate these groups. So let's test this. I will not send all of them. I'll send just few. Let's send 50% using split operator. Now they should collide correctly here. Now this is the basic really, this is all you need. Other than that, it's just a particle system. If you figure this one out, if you set it right, you can do pretty much anything. I will enhance this behavior more. Let's see if I added a sprite here just to see which particles are coming to this event. I will try a different seed. So I want the guys in the back to be walking and avoiding these guys on the front. What we can do is add a flock operator. And let's make all of these to 0 because I don't want them to gather around at this point. I just want to test the avoidance or the repulsion value here. Let's just set this to maybe 5 and 5 follow-up, and I will set the simulation group to 1, 2 because they are going to calculate the bones as well if you didn't do that. Let's go to the top view. Let's give it more value. Let's try 1 actually. Now, as you see, he's going backward. He's trying to avoid other actors here. So you need to balance these up. You need to figure out the logic of these, of the order and the values of the velocity here. One of the things that you need to consider in every event, or you need to put in every event, is a limiter. You're going to avoid particles or actors jumping around or moving around too much or speeding up. I will just put the same value I have for the velocity as a maximum. And now my actors will not exceed that velocity, even if they get pushed back or something. Now, speed operator by particle y is not really correct or not really practical unless you have an army just going in this direction and you don't want them to collide. You don't need them to collide even. So I'll use something that more determined. Let's select the sphere. Yeah, as you see, this is much better solution, but these guys are having a really hard time getting past these. And it will take a lot of time to just test this. Like, I know how to solve this, but I'm just showing you ways to troubleshoot this one here, or this scenario. So what I did is I added a shape operator. And let's switch off the target or the actor, sorry. And let's choose this guy. And let's show the geometry as, and let's show the particle geometry here. Particle geometry. Now in this, but by this way, I can really simulate this quite fast, as you see. And it's the same thing. It's just with the actors gonna load in the animation. That will take some time. So by this method, I can troubleshoot this, add different values, and figure out what makes this work better. And I see now that this is much better behavior I have. And I need also a rotation operator. And you see this guy is avoiding this guy and this guy as well, and he's slowing down and then going through the gap. So let me add also a rotation operator, and I'll set it to travel direction. And by default, I found that 90 on X axis and 180 works the best, or works correctly. And as you see, they just rotate correctly here. But in the beginning, they just rotate in a weird way because there is no velocity, there is no travel direction to work with. So let's set this even age to something like 3, to start at 3, so they have a bit of velocity and rotation can work with that. And they rotate quite harsh. So you can set the interpolation to something like 0.2, and that will make them ease in the rotation value. Great, so let's go to frame 100 and bring back the actor. And let's see if it matches the animation we did. So it's just a cool trick to speed up the process, and then if you are happy with it, you want to just simulate the animation. And as you see, it's pretty much the same behavior. Now I want them to run when they, let's say, reach this point. Okay. So it's around here. So before I do jump to that, I can test or do a walk or a run event. Let's name this to run, and let's split these over here. So let's change this to run, and I will go back to using one actor. And let's add or change the limiter here from 0.3 to something like 2. I think it's, nope. Let's actually bring this one over here. And find the correct value without variation. Make sure that there is no variation value here. And you want to make sure if you copy and paste that you don't have multiply by speed as well. And that's too fast. So let's do 0.5. Still too fast. I'm pretty much doing the same what I did with the walk. So this looks okay. And I will add that value to everything else. Let's add a bit of variation now. And the animation threshold, I'll use that. And yeah, let's put it over here. Now it should work just fine. But I don't know where my rotation operator go. Let's bring that back. Maybe I deleted it by mistake. Bring back my values. Continuous, change it to event age. And let's paste it here as instance. Oh, I didn't put this one. These values over here. And you want to make sure that your orders, your event orders are correct, like the logic here. Like if I set this one up here, it might give me a different result. Or down here. Or like if the object bind is something over here, you'll see that there's slide more. So what I found is object bind. Let's see what I did here. Object bind rotation comes after the flock. You might want it to dominate more. So let's put it over here. And now let's see. Let's do a time test from the walk to the run. Maybe something like 40%. So he would walk and start running. Now, if you see that from walking to run, he just slides because he's speeding up. What you can do is, if you see the velocity here is way high, our run simulation or run speed is something like 2. And he's really going too fast. So if I set this to 2, he should take some time to reach that value. And as you see here, it's much better blending now. So let's put the shape back, actor switched off, all polygons. And let's put more of these actors. And let's see if we can handle this. And you can troubleshoot now real good, or you can see the behavior that they all go at the same time. What you can do is set a time test over here, and that will just give a bit of variation. So they don't move all at once. And I see the flock is not doing great. So let's put it over here. And let's give it more space. And they're avoiding in a much better way now. And let's see the transition to run. Where does it start? Now that's not realistic. So instead of the time test, I'll use the surface test here. So I can now monitor this behavior. It's all working very well. It's all good. Not really, right? What I can do is go to particle physics and set the stiffness to something like 0.2. You don't want a very harsh collision between people. You want to minimize that and make them more fluid-like. So let's give them a less radius. And in the flock here, I'll give it less power. And that looks okay. That looks great. So this needs more testing, as you can see, more values, and you can test with less number of actors to get the better behaviors. And as you see in these examples, I did in different testing, different forces. But if you have the basic layout or basic understanding of using particle physics, and you want to also pay attention to the value doesn't affect the z-axis, or your actors will be stuck on the plane or the terrain. So for the forces, if I went to and select or added a force here, and instead of find target and a flock, if I added a curl operator and force, sorry, and let's do, yeah, let's keep it as it is, and I will do a bigger. As you see, they have a weird orientation here because they are binded to this object, and they're trying to, because they have also a z-axis value here, or a force. So I want to kill that and kill this one too. And now they're just walking around. So that's basically it. Thank you all for watching, and I'll probably do more of these, and this is my first tutorial ever, trying to figure out how to do it. And if you have any questions, please ask in Tyflow group on Facebook. Thank you all. Thank you for Tyson for creating this amazing plugin. See you next time.